Our last part of reviewing our factoring is solving equations by factoring. Recall that the zero factor property is when two or more numbers have a product of zero, then at least one of those numbers must be zero. So using the zero factor property, if we have an equation where we have several factors set equal to zero, then we can set each of those factors equal to zero and then solve for the result. So here we have something that's already factored. Therefore, we can go ahead and set both of these factors equal to zero and solve for both the equations to get the two possible solutions. Therefore, x equals -6 and x equals 3/2. Here we have three factors, x, x minus 2, and 3x plus 4. We can set all of these factors equal to 0. So x equals 0, 2, or -4/3. Now, if the equation is not already factored, then we're going to have to factor it. So we want to write the equation in standard form first, then we'll factor the polynomial, use the zero factor property, and then find the solutions to each of those. And it's always a good idea to check the solution within your original equation to make sure the factors are correct. To start out, we'll go ahead and set this equation in standard form by subtracting 2 from both sides of the equation. And then we'll go ahead and factor it using grouping techniques. Now that it's factored, we can set both factors equal to 0. And we can go ahead and solve. So we have our two solutions for x. Again, standard form, subtracting 4x from both sides. We'll factor using our grouping techniques. We end up with a perfect square trinomial, which is a binomial squared. We only need to set one of these equal to 0 because we'll get the same result for both. So x equals 1/2. Go ahead and put it in standard form. And here, since we only have two terms, we'll start with a GCF for z minus 5. Set both of these equal to 0. And we're left with z equals 4. And so there's our two solutions. Sorry, I did not mean to write 4. I meant to write 0. Apologies. We have a greatest common factor of 3. We have a binomial, and it's a difference of squares. So factors m plus 6, m minus 6. We don't need to set 3 equal to 0 because 3 does not equal 0 and there's no variable. So we set each other expression equal to 0. So m equals -6 and 6. E, we have to expand this out and then factor it. So using distributive property for multiplication, 2q squared plus 2q plus q plus 1. Same on the right, 2 minus 2q plus 6. Combine like terms. Group everything to one side of the equation. We'll factor it. Set both factors equal to 0. And there's our solutions. Last but not least, standard form again. We can factor out the GCF. We can factor this trinomial. Set all factors equal to 0. And solve. Lastly, we can apply using word problems. A piece of sheet metal is in the shape of a parallelogram. So let's start by drawing a parallelogram. The longer sides of the parallelogram are 8 meters longer than the distance between them. So we can use the distance between them as x and the length of the longer sides as x plus 8. The area of the piece is 48 meters squared. Find the length of the longer side and the distance between them. Area of a parallelogram is base times the height. So we know the area is 48 meters squared. The base is x plus 8, and the height is x. We can go ahead and distribute. Write it in standard form. Factor. And then solve. Since we can't have a negative distance, we can ignore the negative 12, meaning the distance between them has to be 4. And then given that the longer side is 8 more than the distance between them, then that means the longer side is 12 meters. Here we have a quadratic function that describes the height of a falling object or projectile. Given the function h of t, how many seconds will the rocket be at 220 feet above the ground? Well, this measures height, so we can substitute height in order to find t, how many seconds. We want to solve for t. We have a GCF, which makes factoring a little bit easier. Let's go ahead and factor out a negative 4. And then our quadratic will factor to be 2t minus 11 and 2t minus 5. We'll set both of these equal to 0. So we have time of 2.5, time of 5.5, and a time of 2.5, which means the rocket's going up, then back down. It reaches the height of 220 feet at 2 points in time, 2.5 seconds, as well as 5.5 seconds on the way back down.